Okay, video 2, continuing our Modbus implementation. We just wrote the function block FB Modbus. Now we want to use this. If you haven't seen that video, you'll need to go back and watch it. Okay, so what we want to be able to do is a function block that is FB Modbus. That's the one we just wrote. We want to be able to give it all this criteria, get all the data, and write our commands. In order to do that, the function block is expecting this read command and this write command. And I found a good way to do this is you use the internal variable, which is p first run. That's internal to Sysmac. This is only true for the first program period or first cycle. This is where we'll define our commands, and I've also found this easier just to do a structured text. I will show you in a second. But what we'll need is we have mb write command, mb read command, and these are the type _s modbus write and _s modbus read. Cool. So that defines the address, the length, and the function code for the command. So let's start in our structured text inline text here. So we'll start with the write data. This will be mb write command dot function equals _mdb write multiple registers. By the way, you might not have this if you have an NX1P2. I don't think they do. I don't think the NX1P2 does Modbus TCP like we're doing here. It might do RTU. I'm not sure. I don't use them much. Okay, next, write command dot write address. We're just gonna start on 31. This might change later because I have my demo setup's a little different than the actual implementation I did, but that'll work for now. mb write command dot write size. So if you remember, in our function block, we had our write data was 0 to 20 of Word. Our read data was 0 to 6 of Word. So our write dot write size is it's actually 21 because there's 0 to 20, so 21. Cool. Read data, kind of the same thing. mb read command dot fun equals this is _mdb read input registers. Kind of another common one is read holding registers, so make sure whatever device you're talking to, you got the right ones. But we're doing input registers. Then we have mb read command dot read size. Read address is in my case it's 31 again. mb read command dot read size. Remember we had 0 to 6, so that's 7 total, 7 words, so 7. By the way, this can be less than this, it just can't be more. So if you want to make this like 0 to 100, I guess you could, as long as there's no issue on the server side of things. Because you only actually write the first, whatever number this is. So that's your commands. Wonderful. Okay, let's fill out our function block here. First, we're going to have our address, which for me, 192.168.249.1. Our read command, mb read command, write command, mb write command, write data. We haven't defined this yet. I'll do that in a second. We'll just do mb success. Global, all caps, cool. mb error, modbus error, global. All right, so we're gonna do a couple more variables here for our data. So we'll do MB write data, MB read data. So it'll be array 0 to 20 of word. This will be array 0.6 of word. Cool. So this will be write data. I'm sorry. MB write data. MB read data. Define the function block. Modbus exchange. All right, and you don't want to just put this on a. Well, I guess you could, but then you'd be. You don't want to just always have it on. It'd be subject to the cycle time of the PLC, which is likely too fast for Modbus, and it's just not a very clean way of doing this. So we're gonna shift R. First, we're gonna have a enable bit, MB enable. To global, MB is enabled. Just good practice for testing for any Ethernet for that matter. So if this is true, we'll do that. So we don't ever want to trigger this unless MB is enabled. Okay, now we got to do a timer. So you need to do a timer, come over here, go to the bottom. We're going to use an accumulation timer. Call this timer Modbus. Our set point. So this is going to be your pull rate from the PLC to the device you're communicating with over Modbus. So I usually do something around 100 milliseconds. So T pound 100 milliseconds. I've gotten this as low as like maybe 20 milliseconds, which I would consider very fast for Modbus. But you can do it if you want. But if you don't need faster than 100, and this is generally pretty good, I wouldn't bother. So when your cycle timer completes, you want to do two things. You want to reset Modbus timer. Do that internals, so we come down here. So every time this completes, it resets itself essentially. And then you want to do Modbus exchange. And we will use this here. So when it's enabled and our 100 millisecond timer completes, we do the execute. If you remember, the execute is a rising edge, so it only requires that true for one cycle to start the sequence. Okay, we're ready to deploy our project and test. So first things first, let's make sure we're all set up. Don't have any errors. If you do this, check all programs. If you have any errors, it would come out here. No errors, few warnings, doesn't matter for this. All right, then you'll set up your communications setup. We are going through Ethernet via a hub. Our address. This is the default address for the PLC. Cool. If you want to change the address, go up to configuration, controller setup, built-in Ethernet, and you would change it here. You would still leave the address from the communication setup, and then when you deployed your project, it would configure it with this IP address. I'm going to leave it. Actually, I changed my IP of the robot I'm connected to. I think I had 249.1. I changed it to 250.2 because that was easier than the alternative, changing everything to 249. But put this as whatever is going to be the address of the device that you want to talk with. All right, cool. We will go online. So this is saying the project is 1.6. My PLC is 1.64. If that happens, you right-click on the little PLC guy here, change device, 1.64. Okay, let's go back online. No error. This is the download, so we will download. Cool. Next, what we'll do in our main program, we can remember we have to enable it. So this enable will turn this on. So this would be like a button on your screen, or you could leave it as like a debug variable just from your ladder, but we're going to make that true. and we're getting success true. So this means it is firing, it's going through our whole sequence, and it is outputting this bit as true, so it's doing what it has to do. Cool. So now let's see our data. So now we have, what do we do? We want to view the table. Pin that. Our data was a read. Right, we want to do our write data. Okay, I think the mistake we need is this MB write data needs to be global. That's what I'm guessing, because I can't view it in the table. So move to global, read data, move to global. So now if you'll open the data, globals, got them down here. Yeah, I think they have to be arrays in order to read them in here. So let's re-download. Okay, so now we have our table with this data. We can display it, you know, however you want. We'll do decimal. Okay, so if I move this over, then I have my Epson robot I'm connected to. I'll look at the data. I know our inputs start at 512, and that happens to be that word 31 that I'm writing to we defined up here. 31. I did have an error, if you saw that. Controller status. We go to tools, troubleshooting, unregistered unit. Oh, I have a new project. There's some IO cards on this unit. So it doesn't matter for what we're doing. I do go over this in a different video, but you can ignore this error. Okay, so let's write, you know, 15. Oh, okay, so we need to enable. This is not a persistent bit, so we'll do that. And now we can see we got our 15. So this is okay, so we got our table. We can see if we change the numbers. There's our 1, 2, 3, 4. Oh, so that's how it works. This is like bit, you know, this is value 1, 2, 4, 8, 16, 32. So as we change these, we get our different bits turning on here. So that's that one. I believe the next one would be this. There we go. So you can see it does indeed change the values. So that works. That's the write. And then this, what we're reading, you can see this is our first one. So if we go 1, 2, 4, 8, 16, 32, 64, 128, we should get a value of 129 in our first read. So we'll do watch MB read data. There we go. Decimal. Decimal is what we wanted. 129, 129. Cool. That's how it works.